Hi guys, welcome back to my YouTube channel. Today in this video we will discuss about automata theory, deterministic finite automata. It is also known as DFA. Come guys, let's start the session. Deterministic finite automata, DFA. Here is a sample diagram of DFA guys. Let's see an example representation of DFA. In this example, we have taken three states called Q0, Q1, Q2. Q1, Q2, Q3. These are the status. The given alphabets are 0, 1. In this given example, we need to travel 0 and 1 from each of the nodes. Like from Q1, we need to transfer 0 and also we need to transfer 1. And Q2 also we need to transfer 1 and also we need to transfer 0. As the same, we need to check for all the three status. In this video, they have already given the initial state is Q1. Q1 has self loop of 0 and 1 is transferring from Q1 to Q2. And also Q1 is a final state where we will check in a transition table, and in this state one input is there, it is self loop of 1, and 0 is transferred from Q0 to Q3. And in Q3, from Q3 there will be two inputs 0 and 1. We need to transfer it from any other nodes whichever possible inputs are there. Like if you write any languages for this DFA, we need to satisfy all the conditions, so that we need to satisfy the conditions, so we need to follow the steps. So that here they have written, here it is represented as Q3 to Q2 0, 1. 0 also transferred from Q3 to Q2, and 1 also transferred from Q3 to Q2. In this transition table, you can see that the stages are Q1, Q2, Q3, and the inputs are 0 and 1, which is present in alphabet. The symbols Q1 transferring 0 to Q1 itself, so that Q1 cross 0. You can see that in a table Q1 and 0, it has a Q1 itself, and then Q1 transfers 1 to Q2, and the same Q2 transfers 0 to Q3, and Q2 transfers 1 to Q2, and Q3 transfers 0 to Q2, and Q3 transfers 1 to Q2. As the same, in this example, we have an initial state as Q1 and final state as Q2. Come guys, let us move into the topic in detail. Example question. Here we have three states. Those are A, B, C, and the input symbols are 0, 1. First, the language is given 0, 1, 0, 1, 1. This is a language. We need to satisfy this language. It is satisfying or not. How we will check? First, the initial state of this DFA is A, state A. We will check that. First symbol of language is 0. It starts from 0 itself. It starts from A. A has 0 self loop, and it is a current state where 0 is present. In the next state, we need to check for 1. Previous one we have already checked that 0 is present in a current state where initial state starts, and we need to check for 1. We transfer 1 from 0 to A to B. We have a transition from A to B. Then we will have 1 in B, in stage B. And the next symbol is 0. We need to check symbol B in stage B, where it is transferred B to A. I think this question is an example for ending with substring of 1, 1. Now we need to check for 0. Our current state is at B. Now we need to check for 0. 0 is transferred from B to A. That's what we need to check. Now current state will be at the position of state A. Then now we need to check about 1 will be accepted or not for the same transition, same DFA. Okay, well, let us check. Our current state is A now. Then we need to check for 1 can be transferred from A to B or not. In this state, 1 will be transferred from A to B, the given symbol. On this stage, we need to check for 1. 1 is transferred from B to any end state or not, because it is an end state we have. So that we need to check that the given question will be satisfied for a machine like if we give any languages, any type of languages, it will be 4 byte or it may be more than that. The machine should accept the input. So that we need to check all the symbols of a language. In this situation, 1 is our next symbol, but we are in current stage at state B. From B we need to we can transfer from B to C, but C is not an endpoint. Is it right? So this given language doesn't accept the machine. See here, the next symbol is 1. It is present at the position of C, or current state C. From current state C we can't go anywhere, so that it is not an end state. In this current DFA, we have start stage as A, and end stage also has A, B both. A, B both are the end states, and we have a start stage A, but both are A, B both are end stage. But also we can travel from B to C. We need to travel 1 from B to C, but we doesn't have any endpoint at the C state. So this language will be rejected from the machine. The machine accepts the string. Process ends in the double circle. Like if you have a start in this example, we can see that if you have 0 1 1 1 as a language, then what it will check the start point is 1 1 1 only. Then we need to check that if 1 1 1 is passing through these states or not. First we need to check for 0. From 0 it will be here itself, and from 1 it will transfer to 1 to 1 1 1 to 1 1. Then again it will transfer. Again if it will transfer means it has 1, then 1 1 to blank space it will transfer, like nothing but here it will comes. Then we need to check that all the symbols are covered or not. Still 1 is there. Then we need to check for last condition 1. We have a self loop. Nothing but any number of ones we can have after 0 1 1. After 0 1 1, any number of 1 it will be covered here itself, and also it is a end state. So in this case the language should be accepted. Build a DFA. Accept the set of all strings over a language or alphabet 0 comma A that ends with 0 0. We have a condition. The DFA should satisfy the condition which ends with 0 0. In this example we can see that we have for 0 0 we have 3 states, nothing but symbols plus whatever we got the language plus 1, nothing but we have 0 0, 2 symbols, then we need to add another one plus 1, then it will be 3, so that we will have 3 states. In this case, first state we need to move 1 and 2. From where we don't know. We need to check that. If we move, we have 3 states, and we also have a language. Then we can easily write it that 0 and 1 from in between the Q0 Q1 Q2. Just take an example, Q0 Q1 Q2 as an example, and in this example you can see that 0 is transferring from the start state is this one, and the end state is the last one. Wherever we can transfer, the 0 is transferring from Q0 to Q1, and again 0 is transferring from Q1 to Q2. How means they have specified the language here. In this case we need to construct a DFA, so that DFA is nothing but we need to transfer 0 and 1 from each state we need to transfer 0 and 1. Then in this from this state 0 is already transferred, then we can give a self loop as 1. Is it possible? Because any other one is not transferring from Q0. No, we can easily write it, and then this state is over. Then here we need to come. In this state what we need to do means we need to check that from this 0 is transferring to next state, but 1 is not transferring. For that, what we need to do, we need to check if we give a self loop, what it happens. If we give a self loop, the condition will be break, then the machine doesn't accept which is ending with 0 0. So that we need to backtrack, nothing but we need to give the transition of this middle stage to backward. From let us example, take it as a q1, then from q1 to q0 we need to transfer 1, then this state has been finished. The next stage is the final state, which has no inputs. In this case, we need to give a the given question is the DFA which ending with z is 0 0, or the machine which accepts the language ending with 0 0. It's nothing but the last terms, last two symbol will be 0 0, so that we can give a self loop here. Is it right? And next we will come to, we have another input called 1, that we can't give a self loop because it will be a error, because we have a question to end with a 0 0, so that we can just give it to backtrack. Like if we give in a previous stage, it will also miss the 0 0 condition, so that we will give to the initial state here itself. Then it will be manageable, or it will the machine will be accepted whichever the languages are ending with whichever a language symbols ending with 0 0. Minimal DFA. This is a minimal DFA example. Minimal DFA is nothing but just we are just converting NFA to DFA. Whenever we are just take an example. We have one NFA. We need to convert that NFA into DFA, so that we will convert with the NFA to DFA conversion process. But the DFA will be a larger is nothing but there will be a many status or useless status, so that we need to reduce those status into minimal size, so that we will use this concept called minimal DFA. You can see this is a DFA we got from a NFA. We are minimized through some procedures what is a proper or reduced states, and it's a minimal DFA. Let us see that. Definition of language L with alphabet A is given as follows: L equal to a power nk, or k is more than 0 and n is a positive integer constant. What is the minimum number of states needed in the DFA to recognize L? N plus 1 state are needed in a DFA to recognize L. Let n equal to 3 and k equal to 1, then the states will be 3 plus 1 equal to 4 states, as here given. If n equal to 3 and k equal to 1, the states are 4. Those are Q0, Q1, Q2, Q3. These are the states. Thank you guys. Thank you for watching our video. This is all about our video. We will meet in our next video. Thank you guys. See you.